Okay, I think we'll get started. We've got over 50 people already joined. So thank you so much for joining us here today for Ecosystem Carbon 101. This is the first in our four-part carbon measurement training series that we're offering here at World Wildlife Fund. So welcome and thank you all for joining us today. Let me just get my slides. So for those of you that don't know me, my name is Emily Giles, and I'm the lead specialist on the Science, Knowledge, and Innovation team here at WWF-Canada. I live just outside of Ottawa in a little town called Perth, Ontario, and I want to recognize that Perth is located on the Anishinaabe Algonquin lands and want to recognize that they are the original inhabitants of this land. So welcome and thank you to all of you for joining us today. We are going to record this session. So if you can't stay for all of it, or if you want to come back and check some of what we covered, you can always check it out. Catherine's going to share for us in the chat there where the learning library is that WWF hosts that contains all sorts of resources and will include this recording webinar as well. So I invite all of you, if you have questions as we go through, please do put them in the Q&A. I know sometimes the Q&A shows up at the bottom of your screen. Sometimes you have to click on the More button to see where the Q&A function is, but please feel free to add questions there and we'll try our best to answer them as we go through the webinar. We're also going to have a dedicated Q&A session at the end of the webinar. So if we don't get to your question as we go, we'll definitely answer it at the end during that Q&A section. And we also do have somebody online today who can help with French-English translation. So if you have a question, feel free to answer it in French and Catherine will help you with that. And any technical issues at all, please email us there at science@wwfcanada.org. So today we'll just do quick introductions so we get a bit of an idea of who's on the call and so that you know who our team is here at WWF. We'll give a bit of a background and introduction to WWF and why we're focused on carbon and carbon measurement specifically. And really the purpose of today's call is to talk about carbon and why it's important and provide a bit of an overview of carbon for folks who've maybe never worked with carbon before or are interested in learning about measuring carbon and what that entails. So we'll give a bit of an overview on that, as well as dig into a desktop analysis to show you how you can do at least a basic analysis of carbon from the comfort of your own home. Then we're going to share with you some resources for carbon for you to check out and investigate further. And then, as I mentioned, we'll have a Q&A session at the end where you can ask questions and we'll do our best to respond to them. So if you don't mind just taking a moment to write into the chat your name, your affiliation and role. And we'd also love to hear where in Canada you are joining us from today. And I'd also like to introduce my colleagues who are on the line today who are going to do the bulk of the presenting. So I'll pass it off first to Claire to introduce herself.
Hi, everyone. Thanks, Emily. So I'm Claire Wark, a specialist on WWF Canada's Science, Knowledge, and Innovation team alongside Emily and Cal. I'm based in Collingwood, Ontario, along the south shore of Georgian Bay, which falls within the territory of the Anishinaabe Nation, along with the people of the Three Fires, the Odawa, and the Potawatomi nations. This land has been traditionally managed by the collective Saugeen Ojibwe Nation. And I spend most of my time at WWF Canada connecting with communities, leading carbon training and fieldwork initiatives, and supporting the carbon community of practice calls. And I'll pass it over to Cal.
Wondering if Cal dropped off. Maybe if in case we lost him, Catherine will go over to you next.
Sure. Hi, everybody. I'm Catherine Beckett. I'm a specialist of freshwater ecosystems here at WWF Canada. So my role today in this webinar will be helping with translation if any questions come up. So translations in French and in English. So yeah, I will say the same thing in French. Bonjour tout le monde, mon nom c'est Catherine Paquette. Je suis spécialiste d'écosystème d'eau douce ici à WWF-Canada. Donc, mon rôle aujourd'hui durant le webinaire va être de faciliter la traduction. Donc, si jamais vous avez des questions en français et vous êtes plus confortable à les poser en français, il me ferait plaisir de les traduire pour les personnes qui vont présenter aujourd'hui et je peux ensuite aussi traduire leurs réponses. Donc, oui, c'est ça. Back to you, Emily.
Okay, thank you both. So Cal is the other one who's joining us today, but it looks like he is maybe having internet problems, but hopefully he'll be back on shortly. So we'll keep going in the meantime. So our key objectives for this webinar is really to give a high-level overview of what ecosystem carbon is and why it's so important. We want to chat about how much carbon is found across Canada and share with you some of the tools that we have to visualize carbon both here in Canada and around the world. And then introduce why carbon measurement may be beneficial for you or your community where you work and why this might be something that you want to look into. And then we're going to get into how to perform that basic desktop analysis. So it's a really great option for folks who are wondering if they want to invest in fieldwork and want to dig in further. You can start with the basic desktop analysis to kind of get an idea of how much carbon is located in that area that you're interested in. And finally, we'll talk about when to consider measurement beyond just that desktop analysis that we're going to cover. So you might be wondering, some of you maybe have never worked with us here at WWF before. You probably know us as the organization with the panda logo, and you might be wondering why we're offering this series on carbon measurement and why we're looking at carbon in the first place. So just as an introduction to World Wildlife Fund, everything that we do at WWF is focused on both biodiversity as well as climate change. So our entire 10-year strategic plan is focused on biodiversity and climate change, and specifically working on nature-based climate solutions. So really we're focused on restoring, stewarding, and protecting those areas that are both important from a biodiversity perspective as well as for carbon. So carbon is one of those common threads that links our project work across the country and has become a key part of the work here at WWF that we're doing. So as part of that work, Claire, Cal, and Catherine and I all work on the carbon monitoring program. And it was developed in response to a need that we heard from a lot of communities and groups across the country who were interested in learning more about how to do some of that measurement and carbon monitoring. And we really wanted to make it accessible and easy for communities to learn how to do it. So this webinar series is an entry point for those who are interested in learning more about carbon. And as I mentioned, this webinar will be available on our carbon measurement learning library, and also in the learning library are a whole suite of other tools and resources that I invite you to take a look at, and it will help you to learn a little bit more about the carbon work that we're doing. So on that note, I am going to pass it over to Claire.
Yeah, thanks. So before we continue with the slides, we're just going to open a short poll to answer some questions as a group. So let me take a moment to pull that up. Okay. Okay, so you guys should be able to see the poll on your end. So this will really help us understand who's joining today and how to tailor the upcoming webinars to meet everyone's needs. All the questions are completely optional, so if you feel like participating and just submitting one answer, that's great. If you want to reply to all of them, that's also appreciated. We'll just leave it open for a minute or so, just to see again who's joining us today. Okay. And I also see that Cal was able to make it back on, which is great.
Yeah, welcome back. Cal, do you maybe want to give a quick intro while folks are filling out the poll?
Yeah, of course. Sorry about that. Sometimes you have to reboot when you're doing these online webinars. My name's Cal. I work on WWF-Canada's Science, Knowledge, and Innovation team. I'm an associate specialist in carbon and ecosystems. And yeah, I'm excited to join this webinar with everyone.
Okay. Leave it open just for a little bit longer. You can see responses still coming in. Oh, it's great. Lots of people participating in the poll. Okay, maybe I will leave it there. So I'll end the poll and then share the results back with everyone. It's great to see that a lot of the folks joining today kind of fall between that somewhat knowledgeable and moderately knowledgeable range. So hopefully there's lots for you to take away from our session today. And then a pretty even spread across the different carbon pools that people are interested in, which is great to see. And then looking down at the barriers which people are currently facing, looks like staff expertise kind of is the one that is the biggest barrier for folks. Okay, so maybe I will end the poll there and we can move on to the next slide, Emily. Thank you. Okay, so what is carbon? In simple terms, carbon is an essential building block for all living things, and that includes animals, plants, soils, and rocks. Carbon moves through all of these living things in a cycle where it's stored in different places until it's released and continues moving through the cycle. The image on the right is a representation of this cycle, and I'm sure most of you have seen this type of visual before back in school or maybe university. But here, carbon stores are shown in gray, and then the processes by which carbon flows are shown in blue. While not shown on this visual, an important distinction is between carbon sources and sinks. If more carbon is being absorbed from the atmosphere than emitted, we consider the store to be a carbon sink. And then if the opposite is true, it's considered a carbon source. Ecosystems and animals can switch between being sinks and sources. So a really good example of this, one that most people will probably be familiar with, is if you imagine a parcel of the boreal forest with trees at various ages, it's going to be a carbon sink. But if that parcel of forest is then subject to a wildfire, it quickly transitions into a carbon source as the biomass burns and all of that carbon is released. The image shown here of the carbon cycle also doesn't indicate the quantity of carbon stored in each of the sources or sinks. However, we know that some ecosystems are especially good at storing large amounts of carbon over long periods. This includes mangroves as well as peatlands. And while we don't have mangroves here in Canada, we actually have 25% of the world's peatlands. And part of that 25% is made up of the world's second largest peatland complex, which is located in Northern Ontario. And so in a few slides, we'll take a look at a national scale map of Canada, and you'll be able to really see how much carbon is stored there. So next slide, please. So carbon can be found across all types of vegetation and sediments, and it's not just limited to terrestrial ecosystems. Green carbon commonly refers to terrestrial carbon stores, while blue carbon is used to refer to carbon that is found in marine environments and coastal ecosystems. And there's increasing interest and research into both green and blue carbon across the country. However, there's significant knowledge gaps that exist when mapping blue carbon and measuring the amount of blue carbon within ecosystems. Similar to how we find stores of green carbon in peatlands and forests, blue carbon is commonly found across 3 ecosystems in Canada. So there's salt marshes, which are found closer to the shore in the intertidal zone, seagrass meadows, which are filled with grassy plants like eelgrass, and then kelp forests, which are found in deeper waters. And you can see in the image here on the right, each of those three ecosystems is represented how they may appear off of a coastline. Okay, next slide. Now that we know a bit more about what carbon is, where it can be found, how it flows, I'm going to discuss a little bit about why it's so important. So ecosystems regulate the Earth's climate by removing carbon from the atmosphere and storing it in vegetation, soils, and sediments. And when these ecosystems are then disturbed, carbon dioxide and other heat-trapping gases can be released back into the atmosphere and lead to the acceleration of climate change. Disruption can include things like severe forest fires, the conversion of forests into agricultural lands, as well as draining wetlands for urban development. Those are just, a few examples. Next slide. So knowing this, it's really important for us to maintain the balance of the Earth's carbon cycle. And some examples of how that can actually be done includes managing fire-dependent ecosystems to ensure that very severe and intense wildfires occur less often. It can include protecting areas with lots of biodiversity and carbon from disruptive human development, as well as switching to sustainable harvesting and forestry practices when developing timber products. Okay, next slide. We're now going to look at how much carbon is actually found in Canada. So we know that there's an estimated 327 billion tons or 327 petagrams of carbon stored in Canada's terrestrial plants and soils. You can see in the visual on the right that PG is noted as the unit. These are petagrams, where 1 petagram is then equal to 1 billion tons, and those are metric tons. So of these 327 petagrams, 94% of carbon is stored in the first meter of soils, and the remaining 6% is stored in plants. You can see here in the visual that soils are further divided in this graph to show that peat and non-peat soils make up different amounts of the carbon stored. So despite peat soils only making up about 12% of Canada's land area, they actually store 32% of the soil carbon. And these numbers provided here are from a peer-reviewed study completed by McMaster University and WWF-Canada back in 2022. Oh, Emily, can you still hear me?
Yeah. Yep, I can still hear you. Yep.
One of my applications decided to shut down. Okay.
Okay. No, you're still good.
Okay, wonderful. So the source for this study is included in the resources section that we'll share later on in the slides, but I also wanted to make it really clear that the numbers shown here do not include carbon found in marine and coastal ecosystems. Okay, next slide, Emily. From that same study by McMaster University, the maps shown here provide a visual of carbon storage across Canada. So on the left, you can see total carbon of soils and vegetation, where the dark purple indicates larger amounts of carbon being stored. You can see almost a band stretching from the northern Yukon down to northeastern Ontario. And this roughly aligns with where the boreal forest is, along with areas where there are high probability of peat soils. And you can also see there the world's second largest peatland complex, which I mentioned previously, is there in northern Ontario in that really dark purple area. You can also see on this same map on the left-hand side, out on the west coast, there's a large amount of carbon stored right on the coast, as well as on Vancouver Island and then north to Haida Gwaii. And then on the right side, we see an interactive version of this map showing the total carbon storage for both biomass and the first meter of soils. This interactive version is found online and is shown at 10-kilometer resolution. However, the raw data from the study used to develop both of these maps is available to download at a 250-meter resolution. And this data will be used shortly in the ArcGIS desktop analysis demonstration we'll be looking at in a little bit. Next slide, please. Okay, I'm going to highlight some other online maps and platforms that are available for estimating and visualizing carbon at regional and global scales. These platforms use different sources of data to estimate carbon, but on each of them, the source data can be easily found. You don't really need to hunt for it, so that's really useful. The first one here is the Nature United Emerald Edge carbon map, which illustrates the forest carbon found from the south coast of Alaska down through coastal BC and to the northern edge of the Pacific Northwest. This map also contains data for carbon flux in forested areas in the region. Next slide. Okay. This next mapping platform is the Soil Grids by ISRIC. This is a global platform that allows users to look at a heat map that shows the carbon stock found in soils at a depth of up to 30 centimeters. So it's not as deep as the McMaster University map, but this offers a global scale. And this platform may also be worth checking out if you're interested in soil classifications or other soil properties such as clay content, bulk density, nitrogen levels, and so on. Next slide. Thanks, Emma. Okay, Soils Revealed is the last platform that I'm going to highlight today. It's another global platform that allows users to view soil organic carbon stock. A key difference, though, between this and Soil Grids is that this platform contains data layers with historic, current, and future predictions of carbon stocks over the next 20 years. Okay, next slide. Now that we've got a bit of an understanding of what carbon is and its importance, along with some tools to visualize carbon storage, let's look at some reasons why you might want to measure carbon. Estimating the amount of ecosystem carbon in your community provides data that can be used to identify regions, to prioritize for conservation and environmental monitoring. It can also be used to develop goals tied to future carbon sequestration projects. And it can be used to inform land use planning workshops, as well as aid in decision-making for municipalities, councils, and regional governing bodies. Next slide. So carbon data may also open the door for partnerships that provide funding or capacity for additional data collection. For example, available carbon data can be leveraged when applying for funding tied to conservation, monitoring, and protection projects. Additionally, carbon data or a distinct lack of carbon data in specific areas may open the door for research partnerships with academics, government, or NGOs. And lastly, initial carbon measurement activities can also serve as a stepping stone to determine if carbon crediting or offset programs are worthwhile for your community or territory. Okay, next slide. Perfect. So we're now moving into a bit of the second half of the webinar, which is going to be focused on completing a desktop analysis. But first, maybe I will explain what a desktop analysis of carbon actually is. So with those unfamiliar, this is a method to estimate carbon in a specific area by using an online mapping platform paired with peer-reviewed carbon data. And completing a desktop analysis of carbon is a really good first step because it doesn't require a lot of time or specialized skills. Really, anyone can do it if they've got access to a computer. It can also be used to determine where future carbon fieldwork can take place and if these areas overlap with other areas of conservation interest. So if you were thinking of an example, if you've got a map showing where species at risk are commonly observed in your community, you can assess those areas using a desktop analysis for carbon, and then being able to identify areas with high carbon storage and high observations of species at risk may then support future land use planning exercises or when you're planning field work. Okay, and so with that, I'm going to pass it over to Cal, who will do a bit of a deeper dive on how to complete a desktop analysis.
Thank you so much, Claire. That was a great analysis and an overview of the carbon cycle, and really showed the importance of estimating these carbon stocks in different ecosystems. I also love kind of seeing those open source data tools that you provided. I think they're super powerful tools that show both the magnitude and distribution of carbon throughout different areas. And I just find carbon maps to be aesthetically pleasing, so I love seeing those open tools there. So building on this information, I want to turn our thinking about ecosystem carbon into more of a practical sense, and I want to do this by demonstrating how to estimate the carbon stock in an ecosystem using these desktop applications. And to complete this desktop analysis or this carbon stock assessment, I'm going to provide do an overview of two common tools used in spatial analysis, and each of them comes with their different benefits and costs for the user. So the first one is Google Earth Engine. This has the benefit of being free, open access, and fairly user-friendly. And the second tool I'll do a brief overview of is ArcGIS. And this has the benefit of performing more complex spatial tasks, but it's at the cost of requiring a paid membership. It's usually an annual fee. And the last thing I'll mention is that after this demonstration, if anyone has any questions or requires further support, please don't hesitate to reach out to our team. We'll be happy to help and clarify things up for you. So on that note, I'm going to switch to share my screen, and we'll dive into the analysis. I hope everyone can see my screen here. Great, thank you.
Yep.
So this is the paper where the data that I'll be using today is from. So this is a paper by Soth et al., and this is a collaborative project between McMaster Remote Sensing Lab and WWF-Canada. The authors used a combination of ground data, satellite imagery, and machine learning techniques to estimate the carbon stocks in soils, forest, and vegetation for all of Canada at a 250-meter resolution. So it's a very high resolution data set of the entire carbon stock of an ecosystem. And all the data from this paper is openly available at the 4TU Research Data Repository. There are 6 data sets provided here, but today we're going to focus on only 2 of them. The first one being carbon stock of forest biomass. So this includes above ground biomass, below ground biomass, and dead woody debris. And the second data set is soil organic carbon, and that will be to 1 meter depth. And if you scroll to the bottom of this page, you see the 6 data sets. So the first 2 are the ones we're focusing on today. And each data set has its own landing page, and it provides its own prescription or description of what is actually involved in the data set. But if you scroll to the bottom, you can click on download all files, and this will download a zip file containing the map data in a GeoTIFF format. So that's a gridded imagery format at a 250-meter resolution. So when you first open Google Earth Engine and you import this data, this is what it might look like. So this is, as Claire had showed previously, this is the data for forest and soils for all of Canada from those two or from that paper. And you can see that carbon and forest covers all forested areas in Canada, and carbon and soils covers all of Canada because soil tends to be continuously distributed throughout Canada, where forests, which is, the carbon stored in trees, is just located in those forested areas. So this is just a visual depiction of what we'll be working with today. So when you get started in Google Earth Engine, this is the landing page you're going to be taken on. And on the top right, you'll see a Get Started tab. So you want to click Get Started. You'll be referred to the Get Started Using Google Earth Engine page. And here you can either register a cloud project, or you could simply just click here to go straight to the code editor. The only benefit of registering a cloud project is if you're going to organize multiple projects, it's beneficial to kind of have your own. But for the purposes today, we'll just click straight to code editor, and you'll be brought into the Google Earth Engine mapping tool. Now I can spend a lot of time going through Google Earth Engine and how to use it, but for today's purposes, we're just going to look at how to do a carbon stock assessment using a Google Earth Engine tool provided today. So the first step with doing a carbon stock assessment in Google Earth Engine is to draw a study area boundary. And you can do that using the Draw a Shape icon located on the top left corner of the map here. And what this allows you to do is to place points on the map, and you can place them anywhere. And this will anchor the point down onto the map. And when you click another point, it'll draw a line between those 2 points, and that will act as the boundary for any area you're interested in. And you can continue placing as many points as you like. And you can zoom out if you're interested in like a larger area, and you can also zoom in, and you can get very, very fine detailed, and you can put as many different points as you will like. But the main point after you want to draw your study area is that you want to click the first point that you placed, and this will close the loop, and the entire study area boundary will be drawn. So if there's an area of interest that you want to highlight and you want to get very specific, you can zoom in, place 100 points, and make your way back to the first one. If you're just looking for a general area, you can just do a general map. There's even a tool here on the right here that just allows you to draw a rectangle anywhere on the map. So that's just a quick introduction on how to draw a shape in Google Earth Engine. Next, I'm going to use a tool provided, an app that was developed to actually calculate the carbon stock within these different polygons. And I already have it preloaded into here, but we'll provide that open access. We'll provide the link to that after the presentation here. But once you kind of get to this page and you load in the data, you just want to click Run. And what's going to happen is that a panel is going to appear on the right-hand side here. And this is going to walk you through to how to actually obtain the carbon data within these different polygons, these different study area boundaries. So here's the tool, desktop analysis of carbon data. The first step is you want to choose whether you drew your study area or whether you want to upload a shapefile. So maybe you have an area that you already have mapped out and you have a shapefile of that. I'll show you after how to bring that in and use that. But today, or for the moment, we're just going to use the shapefile that we drew here. So I'm going to click Draw Study Area. Here's a little prompt that reminds you how to draw the study area using the Draw a Tool shape. And simply, I'm just going to click Calculate Carbon Values. And below is going to pop out a little summary of both the soil and the forest carbon data. So 2 values are shown here. So you have the mean soil carbon stock, and that's in kilogram per meter squared. You have the mean forest carbon stock, again, in kilograms per meter squared. In brackets, you have the standard deviations of both. And then below it, you have the total forest carbon stock. So the total amount of carbon in the forest in that entire study area that you drew. And this information can easily just be copy and pasted out and used in whatever to try to support whatever goals you had in mind. The second task I want to show you today is, if you had a shapefile in mind, how to actually bring the shapefile into Google Earth Engine and run the exact same analysis. So first, I'm just going to delete the polygon we drew, and I'm going to go to the Assets tab, and I'm going to click New. I'm going to click Shapefile, and it's going to prompt me to select a file from my desktop. So here, I'm just chose a municipal boundary that was familiar to myself, so I'm just doing the Caledon boundary municipal boundary. I'm going to give the boundary file a name, so Caledon boundary, and I'm simply just going to click upload. And if you go to the tasks panel on the top right here, it'll show you that this shapefile is currently being ingested. It might take a minute or two, depending on how complex the shapefile might be. But once it goes from being gray to and once it turns blue, that means that the shapefile is fully ingested, and you can simply go back to assets, click refresh, and the shapefile will appear here. So I already have a Caledon boundary file because this might take a minute or two, so I'm just going to jump ahead. But you can click the arrow beside the boundary and that'll import the shapefile to the script. And similarly, you'll just run the exact same tool that we just used for the study area that we drew. We'll wait for that panel to pop up on the right. And instead of clicking draw study area, we're going to click upload a shapefile. And we can calculate the carbon values of that shapefile. And similarly, here it input the shapefile that we were interested in. So this is the municipal boundary of Caledon. And those same soil carbon, forest carbon, and total carbon stocks will be output on the right side panel here. The last feature of this is that if you were interested in getting a visualization, maybe you want to use the satellite imagery and you want to see what the soil carbon looks like within that specific boundary, you can simply just select Explore Carbon Layers. And that will overlay the different carbon layers that we just analyzed right onto the map for you. And you can select off, if you just want to look at forest carbon, you can select off soil carbon. If you just want to look at soil carbon, you can visualize that as well. So that's just a quick little introduction and a quick summary of how to use the Google Earth Engine suite of tools to calculate carbon values. And the last thing I want to demonstrate is that yes, there's multiple applications for this type of software. So as an example I'm showing here, I have a preloaded multi-polygon, which means that I drew the shape on the left, which is a wetland area I was interested in, but I also wanted to include an adjacent wetland area, and I wanted to calculate the carbon stocks of these two areas together. So I simply just drew one shape, closed it, drew the other shape, closed it, and simply just selected the draw study area and clicked calculate carbon values. And it calculated the mean and total forest carbon and soil carbon stocks for those two areas combined. So it's a cool little feature of this app. And the last one I wanted to demonstrate was that it also supports fairly complex shapefiles. So this is the Niagara Escarpment plan boundary. And this is a fairly complicated shapefile. I have a pretty high resolution boundary. And you can still import it the exact same way how I did the more simple municipal boundary. It might take 3 to 5 minutes, so it takes a little bit more time just to load in all the data. It takes a little bit more time to calculate the carbon stocks. That's why I pre-loaded it here. But I just wanted to demonstrate that it's applicable to complex shapefiles as well as the more simplified ones. So that kind of sums up the Google Earth Engine aspect of it. But I wanted to quickly just go over one other tool that is common in doing this desktop analysis, and that's the use of ArcGIS spatial platforms. And the benefit of this tool is that you can calculate the carbon stocks of different polygon areas at the same time, and you can do it separately. So that's just a cool benefit of using this. So I'll do a quick demonstration of that right now. So with ArcGIS, you have to you download the carbon files as we showed below. You want to download or obtain those shape files that you're interested. So you need to have the shapefile boundaries, and you simply just go to the catalog and import all the data. Now this can take a couple of minutes, so I have the data preloaded in, but it's simply just in the catalog pane here, and you right click and just add the layer to the map. So I do that, add to current map right there, and it will import the boundary into the map. Similarly, if you want to visualize the different data, you can simply just right click on symbology, and you can change the different color layouts of the different map layers. So here's the soil carbon layer. I don't know why I aesthetically like soil carbon a little bit darker than the forest carbon, so I have it in a purple hue here, but you can change that around as well, just for whatever your taste is. So if you want to calculate the forest carbon and the soil carbon stocks within that boundary area, we're going to have to use a tool that's called zonal statistics as table. And you can find this in the geoprocessing under tools. So here you can select the different shapefile you're interested in. So we'll do that Caledon area that we're interested in. Because it's only one boundary, the zone field is not an important feature, but it just has to be identified. And you can choose the different carbon layer you're interested in. So for starters, we're going to do soil carbon. We're going to give a name to the output table. So you can just do Caledon and simply just click run, and it'll calculate the carbon stocks within that Caledon boundary that we had. Here, I'll show the layer a little closer. And here we are on the left side under contents. If you click open table, it'll show all the statistics that were calculated for the soil carbon in this region. So you have the mean was 15.69 kilograms per meter squared. You have the area of the polygon in meters squared, and you have the standard deviation. So similar to the Google Earth Engine tool, you have a study area boundary and you're extracting the carbon values from there. And we can do the same with forested. What I want to show with ArcGIS is that you can actually calculate it for multiple polygons at the same time, and you can get separate analyses for each. So as an example, I brought in the Lake Simcoe watershed boundary files. So each one of them is a sub watershed boundary that's used by the Lake Simcoe Conservation Authority, and it's all open source GIS. And I want to use the exact same tool that I just used, so the zonal statistics as table. I want to use the Lake Simcoe watershed, but for zone field, I want to select the different sub watersheds. And this time I'll calculate forest carbon stocks, and I'll give it a name instead of Caledon. I'll name it Lake Simcoe. And similarly, I'll run that, and it'll calculate the carbon stock for each of these different sub-watersheds independently, and it'll output them as a table over here. So you can see if I right-click, open, for each of the distinct sub-watersheds, we have the mean forest carbon, the standard deviation, and the area of the watershed in meters squared. And there's also tools in ArcGIS where it allows you to visualize the data in multiple colors, so you can provide a unique value for each of the different sub-watersheds. So this, I'm going to stop sharing my screen, as this concludes the desktop analysis demonstration. I'll also ask Emily to bring the slides back up, and if you wouldn't mind going to the next slide, we've provided here just, a quick a quick, easy step guide for each of the different desktop analyses. So this one here is just a quick refresher on using that Google Earth Engine script. And then if you go to the next slide, please, Emily, it'll also show just a quick step-by-step of how to use ArcGIS to do the desktop analysis. So as I mentioned earlier, feel free to reach out with any questions to our team. And on that note, I'll pass the mic back to Claire. Thank you for listening.
And Claire, you're muted for some reason. We're not able to hear you. Oh, and now it looks like Claire's. Oh, we lost Claire. Okay. Well, thank you for that demonstration, Cal. And you'll probably notice that there are some questions that have come in the chat, and a lot of them are directed specifically to you and the overview that you just did. So if you're able to answer any of those in the chat, that'd be great. Otherwise, we can discuss them at the end during the Q&A section when we go back. So
Hey,
Oh, there's Claire.
Yep, I was just gonna say, can you see me? Okay, perfect. Sorry about that. Okay, so thank you, for providing those demonstrations, Cal. So looking ahead, desktop analysis can be really useful as a first step for those with limited time and resources, because it can give you that snapshot of estimated carbon in an area of interest for yourself or for your community. But in certain scenarios, this might not actually be adequate for reaching your project goals. Some examples of work that require a bit more involved carbon estimation include things like if you're interested in estimating carbon in an area where there's very limited field data informing the peer-reviewed papers you would be referencing in a desktop analysis. And then if you are looking to estimate carbon in a forest that was very recently burned or affected by a severe storm. Additionally, if you're looking for estimates of carbon in soils deeper than 1 meter in depth, you'll need to do additional work on those measurements. If you're interested in estimating carbon in coastal areas, and then finally, if you know that you would like to develop a carbon crediting or offset program in the future, that desktop analysis might be useful for a day one kind of look at the carbon in your region, but you're going to need more information and more data to continue with that work. So next slide, Emily. Yeah. So what comes next after the desktop analysis is the collection of data on the ground through field measurements. Field measurements for carbon can be taken for trees, vegetation, soils, and coastal sediments. And in the upcoming webinars, we will be covering sampling design along with the methods for tree surveys and the collection of vegetation and soil samples in the field for carbon analysis. So if you're interested in learning more and you don't want to wait for those webinars, you want to know right now what all of that work involves, you can check out our Carbon Measurement Learning Library webpage, and it's got videos as well as comprehensive PDF guides for separate carbon pools. Next slide, Emily. Yep, and so this is just a resource page. So right now you can't access these links, but when we share the slides out to the group following this call, you'll be able to access all of the links and resources that we've mentioned throughout the webinar today. Okay, next slide, Emily. Perfect. So we'll now take some time to respond to questions. I'm not sure, Cal, if you got a chance to look at some of the ones in the Q&A, but Emily, maybe I'll pass it over to you.
Yeah, thank you. There's some really good questions coming in. And I wanted to start with the first one here from James, who asked, when Claire was presenting the national map on carbon, James asked the question if there's any similar numbers for aquatic environments. I know of a couple of data sets, and I'll put those in the chat to share those data sets. But I'm not sure if any large-scale national analyses has been done similar to the work that McMaster and WWF did. Cal or Claire, do you know the answer to that? Or do we just have individual data sets that folks can look at?
Yeah, so as far as I know, there's just individual kind of smaller scale regional data sets versus a national scale or global scale data set available. I see Cal's typing an answer, but maybe he'll jump in after.
Yeah, Blue Carbon Canada, I know, has some studies, and I've got the links to that I'll show, as well as another one that I've got here from our folks who do GIS. So I'll share that in a moment. And it looks like Cal is typing. Oh, he's got some of these answers. So James also had the question here of what is the minimum size limit for shapefiles size to calculate carbon. So Cal is saying that any shapefile size can be used, and the resolution of the carbon data provided here is 250 meters by 250 meters. So any shapefile smaller than that size will be the same value as the grid that area overlays. Hopefully that answers that question for you, James. Okay, another question here from Jessica that we haven't answered yet is, can these data layers help us estimate the amount of additional carbon stored by a wetland restoration project? It's a very, very good question. Jessica's also wondering if we're going to talk about this in perhaps an upcoming webinar. Claire, I'll pass that one over to you.
Yeah, thanks, Jessica. So if you're looking to kind of assess the amount of carbon stored through this restoration project that you're doing, you will need to do actual in-field monitoring and measurement in that area, because if you're using existing data, it won't actually be capturing that restoration activity that you've completed. So it will have kind of historic information depending on the date of the source data, but it won't have any kind of information on your restoration activities. So that would be a scenario where you might want to consider doing carbon measurement, and maybe not even, depending on what type of restoration you're doing, maybe not even, the first year following your restoration activity, but make up a plan for a longer term kind of carbon measurement and monitoring. And in terms of if it will be talked about in the future webinar series, we will talk about more specifics related to the methods involved in carbon measurement for that type of ecosystem.
Okay, great, thank you. Another question here from Sally asking if similar data sets exist for freshwater environments that could be used for desktop analysis. Cal, I'll pass that over to you to answer live.
Great, thank you, Sally, for your question. There's definitely an emerging field that I've heard called multiple names. One's freshwater carbon, the other one I've heard is teal carbon. And it's definitely an understudied aspect of ecosystem carbon measurement. And I think there are beginning to see studies on freshwater environment carbon, but I don't think any data set or any large scale mapping product on freshwater environments has been mapped. The only ones I can see are specific to maybe freshwater wetlands, but those would they wouldn't necessarily include open water bodies or riverine systems. So hopefully soon we'll see more of these freshwater environments be incorporated into these large scale maps. But yeah, as of yet, I don't know if anyone knows. I'd love to see them because I know it's an emerging field. Yeah, thank you for your question.
Yeah, actually, Chris, who's on our GIS team just sent me a couple of links there that I put in the chat for a couple of data sets that she's aware of. So hopefully that's helpful. Okay. Chelsea has a technical question, and so Cal, I'll pass this one to you, that Chelsea's getting the same carbon values every time she draws a new polygon in Google Earth Engine. Is there something that she needs to reset in the script? Not sure if you are able to help with that one live.
It's hard to address individual problems without actually seeing the script, but there is a reset function on the top of the console. I don't know if maybe it helps if I share my screen and show that.
Sure, and it's also one of those things that, as Cal mentioned, our team is available after the webinar to help through specific challenges like this, and we can help even if we went over the process and you're still not comfortable doing it on your own. Our team is always happy to help run it for you. So that might be one that's we should follow up with after, Chelsea.
That sounds good. Perfect.
Okay.
Yeah, no, please follow up. I'd be happy to go over that one-on-one.
Okay. Okay, another one here from Jessica, also for you, Cal. What does the PCT 90 field mean in the .fhp attribute file in ARC?
That's an interesting statistic I've never actually seen used, but you can set the percent at anywhere between 0 and 100, and it'll attain whatever value is at that position. So if you set the PCT to 50, it'll obtain the median value, like the value that is between 0 and 100% of the range. So if you select 0, it selects the minimum value. If you select 100, it selects the maximum. So 90 just means what's the 90th value, and it helps just understand like the distribution of the data. Not a super useful statistic, but it's one when you select all in ArcGIS, it will provide with you. I hope that helps.
That seemed very clear to me. So hopefully that helps for Jessica as well. Thank you. Last one that we've got so far is from Vanessa asking if there is a data dictionary for the raw carbon stock data layer that explains the fields and units of measurement. It's a good question. I don't know who that might be applicable to, Cal or Claire, if either of you have the answer for that one.
I don't mind jumping in. I don't know if, and Claire, please feel free to add on. When I presented the different data layers and each one had the landing page, the description of each of the data layers shows exactly what comprises each of the different data that's provided. So if you click through, you should see that description. In terms of having a full data dictionary, it's probably there's gonna be a little bit of jargon from there. But I'd say start there, and it should answer some of your questions regarding the different fields and the units of measurements. I'll provide a link in the chat to that answer.
Okay, great. Thank you. So those are all the questions that we've got so far through the Q&A. But again, we're always happy to help if you want to reach out to us with follow-up questions, or if you would like some help going through any of the things that we chatted about during the session today. So on that note, I'll pass it back to Claire.
Yeah, thanks, Emily. So if you haven't already, please register for the next webinars in this series. Someone from our team, oh, yep, I see Catherine's added the link below. So you can just click on those links to register for each individual one. Or if you are interested in circulating with your network, reach out to us and we can send you the invite over email. So on February 26th, we've got a webinar on soils and sediments, and then on March 5th on vegetation and trees. And in both of those, we'll be talking about green carbon as well as blue carbon. And then on March 26th, we'll be discussing how to use drones and ROVs for environmental monitoring. We're also hosting our next Carbon Community of Practice call this April. So if you're interested in being part of a growing community of practitioners and scientists working on carbon across Canada, please reach out to us. April's meeting will be focused on wildfire and carbon, which is pretty exciting. Okay, next slide, Emily. Wonderful. So thank you everyone for joining the webinar again today. I don't see any other questions in the chat. So yep, as Emily said, feel free to reach out to us. We've got our email address there. And so if we didn't answer your question or you have some follow-up questions about using those tools Cal showed today or about future webinars, just send us a message. Our team would be more than happy to connect with you. So thank you.
Yeah, so on that note, we'll wrap up. And thank you everybody for joining us today. And thank you to Claire and Cal for presenting and presenting in such a clear and concise manner. All right, bye everybody.